There is a number printed on the side of the space industry, and it's about $70 million. That's roughly what it costs to launch a SpaceX Falcon 9. But that number is a magician's hand. It's the one you're meant to look at. Because the real story of this rocket isn't how much a launch costs. It's how much it costs to put 1 kilogram, your phone, a bag of sugar, your own body weight, into space. And that number didn't drop. It fell off a cliff. So how much does it really cost to leave the planet? Start with what you're actually paying for. A Falcon 9 is about 70 meters of aluminum, lithium alloy, kerosene, and liquid oxygen. At the bottom, a first stage with 9 engines, the part that does the heavy lifting off the ground. On top of it, a smaller second stage with a single engine that carries the payload the rest of the way to orbit. And capping it all, a nose cone, the fairing, that protects the cargo on the way up. 3 pieces. And for the first 60 years of spaceflight, every one of them was used exactly once. Then thrown into the ocean or burned up. Picture buying a brand new airliner, flying it across the Atlantic once, and then sinking it. That was the business model of getting to space. So let's open the bill and see where $70 million actually goes. Start with the obvious guess, the fuel. A rocket is basically a controlled explosion, so surely the fuel is where the money burns. It isn't. The propellant for an entire Falcon 9 launch, all of that liquid oxygen and rocket-grade kerosene, costs around $300,000. $300,000. On a $70 million launch, the fuel is about 1% of the bill. It costs roughly what a small apartment costs. Remember that, because it's the thread that unravels everything. If the fuel is nearly free, then the expensive part of a rocket was never the flying. It was the rocket. Take the nose cone. 2 halves of carbon composite that shield the cargo through the atmosphere. They cost about $6 million a set. And here's the first crack in the old way of doing things. SpaceX fishes them out of the ocean and flies them again. A $6 million part, recovered with a boat and a net, and reused. That alone quietly cuts a few million off every flight. But it's the warm-up act for the main event. The second stage, the upper engine and tank that finish the trip to orbit, costs around $10 million. And this one, SpaceX still throws away. Every flight, it burns up. $10 million gone on every single launch. Sit with that, because it tells you something important. Even the most reusable rocket on Earth still sacrifices a $10 million machine each time it flies. Which makes the next number the whole story. The first stage, the booster. 9 engines, most of the height, most of the muscle, and most of the cost. An unflown Falcon 9 booster runs north of $30 million to build. It is, by far, the most expensive single object in the entire stack. And for 60 years, this, the priciest part, was the part everyone destroyed first. It did its 2 minutes of work and dropped into the Atlantic. Every flight, every program, every country build a $30 million machine, use it once, lose it. Then SpaceX did the thing that sounds simple and took 20 years and a graveyard of crashed prototypes to achieve. They flew the booster back, upright, onto a ship, and caught it. A single Falcon 9 booster has now flown 20 times and more. Take a $30 million machine, fly it 20 times, and the cost of that booster per flight stops being $30 million. It becomes a couple of million. The most expensive part of going to space went from a 1 time loss to a rounding error. That's the trick. That's the entire trick. So stack it all up. The booster, amortized across its flights, a few million. The expendable second stage, 10 million. The recovered fairing, about 3. Operations, refurbishment, the recovery fleet. The range, call it 4 million more. The propellant, basically a rounding error. Add it together, and the real cost to SpaceX of flying a Falcon 9 lands somewhere around $32 million. The customer pays about $70. The gap funds the next rocket, the satellites, the future. But here's what matters: a launch that genuinely costs 30-something million. In a world where the old way cost 10 times as much per kilo. Which brings us to the only number that was ever really the point. Forget the price of the launch. Ask. Instead, what does it cost to put 1 kilogram into orbit? Because that's the number that decides whether space is a place only superpowers can reach, or a place anyone can. In the era of the Space Shuttle, the pinnacle of the old, throw it away approach, putting 1 kilogram into low Earth orbit cost about $54,500. $54,000 per kilogram. A Falcon 9, reused, brings that down to roughly $2,700 per kilogram. 4,000 to under 3,000. The cost of reaching orbit didn't shrink. It collapsed, roughly 20 times cheaper, in a single generation. And it didn't happen because the fuel got cheaper, or the metal got cheaper. It happened because we stopped throwing the rocket away. Let's make that a number you can feel. Take yourself, say, 80 kilograms. In the age of the shuttle, launching your own body weight into orbit would have cost about $4.5 million. The price of a mansion. Your body in space for the cost of a house with a gate and a pool. Today, on a Falcon 9, that same body weight costs around $200,000. Not a mansion. A house, and in plenty of places, barely more than an expensive car. In one lifetime, the price of putting a human-sized mass into orbit fell from buy a mansion to buy a car. That is the hidden cost of a SpaceX launch, not the $70 million on the invoice, but the floor that dropped out from under every kilogram. The $70 million price tag was always the magician's hand, the number you were meant to watch. The real number was hiding in the smallest unit. There is the cost of a single kilogram. And it fell off a cliff because someone refused to keep sinking the most expensive machine ever built after one short flight. That's what we do here. We find the number that's actually changing the world, hiding behind the one on the receipt. Next time, the cost of moving a single shipping container around the planet. And why the cheapest part of almost everything you own is the journey it took to reach you. Word count, spoken body, approx. 450 words. First draft pending CEO approval and a fact-check pass. All figures flagged in research. MD must be verified. The TG figures and the body. Weight math must be recomputed against a single locked payload assumption before publish.